Okay, so we're going to be doing FRQ number 6, and this is calculator enabled. So some of these you're going to have to calculate some values on your calculator. We have a chart to start out with, and it says water is pumped into a tank at a rate modeled by W of T equals 2000 e to the negative T squared over 20 liters per hour from 0 to 8, where T is measured in hours. Water is removed from the tank at a rate modeled by R of T liters per hour, where R is differentiable and decreasing from 0 to 8. Selected values of R of T are shown in the table above. At time T equals 0, there are 50,000 liters of water in the tank. So A says, estimate R prime of 2, show the work that leads to your answer, and indicate units of measure. So anytime we want a derivative, it's the same as slope. So I'm going to find the slope to the points closest to 2, and that would be a good estimate. So for A, I'm going to find the slope between 3 and 1. So I'm going to find my y values, subtract those, 950 minus 1190 over 3 minus 1. So that gives me negative 240 over 2, which is negative 120. Now it says indicate units of measure. So this would be liters per hour, because it's already that, but now we're taking the derivative again, so per hour. Okay, part B. Use a left Riemann sum with the 4 subintervals indicated by the table to estimate the total amount of water removed from the tank during the 8 hours. Is this an overestimate or an underestimate of the total amount of water removed? Give a reason for your answer. Okay, so I'm going to first start with my left Riemann sum. So Riemann sum, we're going to use a rectangle. So I'm going to first start with my first interval here. So my base would be the distance between 0 and 1. So that would be 1 times my left height would be 1340 plus my next rectangle, the distance between 1 and 3 would be 2 times my left height is 1190 plus the distance between 3 and 6 would be 3. My left height is 950 plus the distance between 6 and 8 is 2. My left height is 740. Okay, so you would then plug that into your calculator. And so if you want to pause it and check your answer, that would give you 8,050, and I want to make sure I label that. That should be liters. Now, the second part of that question is asking if this is an overestimate or an underestimate of the total amount of water removed. So if we look at this function, here we have the rate. So the rate looks like it's decreasing over time. So we have a negative slope, but the rate is also decreasing. So that would mean that our graph would end up being concave down. So anytime we have an concave down graph, our graph should be an overestimate of our actual value. So let's just model this a little bit so it makes a little bit more sense. If I were to plot these points, I'm just going to do it up here. 0 and 1340. 1, it's going down, right? Now, if I did a left Riemann sum, so I took my left height and went over every time, here's my actual graph, would look something like this. The actual area would be less than the area that we're calculating because that left Riemann sum jumps it over the graph. So I think I said that it was concave down, but that wouldn't be true. So scratch that. That one is actually concave up, but it wouldn't matter if you drew a graph and thought about what a left Riemann sum would look like. Would it go over the graph or under it? In this case, it would go over because our graph is decreasing. So it says give a reason for your answer. So because our graph is decreasing and a left Riemann sum overestimates the area. Okay, so next we're going to go to part C. Part C says, use your answer from part B to find an estimate of the total amount of water in the tank to the nearest liter at the end of 8 hours. So we start with, it says right in the directions that there are 50,000 liters in the tank at the start. So I'm going to take that into account. Plus the amount of water that's being pumped in. So this right here gives us the rate that we're pumping water in. So I'm going to write that down. Water pumped in minus the water that leaves. So let's see where we can get these numbers from. So we're starting with 50,000 plus the water that's being pumped in. So they give us a rate that the water is pumped in. So that's 2,000 e to the negative t squared over 20. But I don't want the rate, I want the actual amount of water that was pumped in. So I'm going to take the integral of that. And I want the integral to go from my start, so 0, to my finish time, which is 8. Minus how much water is leaving. So we already know that because we figured that out from part B. Water removed, and we got 8,050. So the only thing I really have to figure out is this part right here. And we have a calculator that will do that for us. So on your Inspire, you're going to go to your main screen, menu, calculus. You're going to integrate it. So go ahead and figure out that number. I'll give you a few minutes, or you can pause it and then check your answer. And then go ahead and add the 50,000 and then subtract the 8,050. So I got 7,836. So I'm going to add the 50,000 to that, minus the 8,050. So 49,786.195 liters. So I'm going to write that down. Now for full credit, you want to make sure you write down everything you plugged into your calculator. So even though you did all this on your calculator, this is the most important step right here, is writing down what you typed in. Okay, part D. For t between 0 and 8, is there a time t when the rate at which water is pumped into the tank is the same as the rate at which water is removed from the tank? Explain why or why not. So what we're going to do is we're going to see when they're the same. So I want to take the rate of the water coming in, so W of t, and I'm going to set it equal to the rate leaving, R of t. So I can do this on my calculator. I can graph both of these and see where they cross, or I can move everything to one side, set it equal to 0, and find where it equals 0. Okay, so let's go ahead and do that. Now, looking at this, I have W of t equals R of t. I also have WT minus R of T. Now W of T we have a formula for, 2000 e to the negative t squared over 20. And the rate that is being removed comes from this table up here. So we don't have a formula for that. So we're kind of like stuck here because we don't know the formula for that. So what we're gonna do is let's go ahead and start with the endpoints and see what's going on there. So I'm going to find W of 0 and R of 0. And you'll see why in a minute. W of 0, if I plug into my formula here, I get e to the 0, which is 1, so 2000 is W of 0. R of 0 on my chart is 1340. I'm also going to find the other endpoint, so W of 8 and R of 8. So W of 8, if I plug into this formula here, so that would be 2000 e to the negative 8 squared over 20. That gives me 81.524. And then R of 8, I pull from the chart up at the top is 700. Now, I know that we're setting these equal to each other, or if I subtract them, we're finding where they equal 0. So if I do that for both of these, if I find W of 0 minus R of 0 over here, that gives me 2000 minus 1340. So 660. Over here, if I do the same thing, W of 8 minus R of 8. I get a negative answer, negative 618.476. So what I'm showing here is that at the beginning, their differences in rates is 660. At the end, their differences in rates is negative 618.476. So as long as these are continuous and differentiable functions, because my rates go from 660 to negative 618.476, I would have to have a value where they're equal to 0. And that's pretty much the only way we can do it because we don't know the formula for R of T. So that's the issue that we have. But if we can do the endpoints and prove that zeros in between these two endpoints, then I just proved that you would have to have a time when the rate at which the water is pumped into the tank is the same as the rate at which the water is removed from the tank. So we would say yes. And it says explain. So most of the time when you have to explain, you have to use calculus to do this. Now this one, when we prove that something is between two heights, that's the intermediate value theorem, or you can abbreviate it as IVT. So part D was definitely the hardest part of this question. If you got a question like this on the AP exam, I would expect you guys to be able to do A, B, and C pretty easily. D is definitely trickier, but you want to think about what they're asking. Use your calculator if you can. Try anything, write something down, try plugging things in, see if that helps you get anywhere.